What's today? 40-minute sessions, each session 30 minutes, with 10-minute questions for you guys. And let's hand over to our first speaker.
Okay, so since we have 40 minutes between for each slot, and there's no break between them, so we'll give you a heads up 10 minutes before the end of the speak. Okay, last 5 minutes for Q&A, and then time the next speaker to arrange himself for his next slot. Thank you very much.
Can you hear me? No? What if I move this all the way up here? Can you hear me now? Is it any better? Okay, so, good morning. It's good to be here. My name is Ganeti. I work for GRNet. I'm the technical lead of the Synnefo project. I'm here to talk to you about how to combine Synnefo, plus Ganeti, plus Archipelago, plus Ceph to provide unified storage for cloud resources. Now, Synnefo is our cloud platform. We built it based on Ganeti. Ganeti is the best tool for virtualization management out there. You can see the code that Windows has tomorrow morning, same slot. Archipelago is our custom storage layer that uses multiple storage backends, and we use Ceph to provide a storage backend for Archipelago. This is what I'm going to talk about. Now, I'd really like to base most of the presentation in a live demonstration, but I can't do it right now because the network is way too slow. It's got way too much latency. So if you could just, just for once that you can also listen to me, turn off your wireless, and we could try using the links. And if it doesn't work, then we're going to have to describe and imagine what's going to happen. But certainly better, we can actually see it taking place, right? Okay, so where did it all start? Synnefo was built initially to power GRNet's public cloud service. We call it Okeanos. It's Greek for ocean, because it's a good name for a vast cloud service. Design started late 2010. We're in production since July 2011. We have been running our installation ever since. It's a single deployment. We've migrated it from version to version. We still have VMs that have been created from this time. We're still alive. I mean, we didn't have a downtime when the whole data center lost power, but okay, we didn't have something to do about that. We're now at more than 5,000 users. We have more than 7,000 VMs running. We sold more than 250,000 VMs and created and destroyed more than 70,000 virtual networks, which are pretty good numbers. We scale, it works. Okay, how did it work and how did we build it? We wanted to build an Amazon-like service in the sense that it provides compute, storage, and networking capabilities. We wanted the VMs to be persistent, meaning the VMs should be able to withstand transient hardware failures. How do you do that? I'll be talking about that right next. Everything we would do with the open source Synnefo is to close BSD license. You can download it if you want, you can deploy it yourselves, you can go see our demo site, which I'm also be using for this presentation. We wanted to create production such as a service. And we wanted a user interface that would be as simple as possible because our target group was students and researchers who didn't actually have any previous exposure to cloud infrastructure. So how can we build that? What kind of tools can we build? Why is it difficult to do? Everything would be based on commodity hardware, no storage area arrays. How do you do virtual machine migrations if you don't have any shared storage? Because we wanted the VM to be persistent and resistant to hardware failures. Contrary to most cloud approaches, we treat the VMs as our pets. People will say that cows are cattle, that you have 1,000 cows and you let them go out in the field and they eat grass and they bring you back milk. And if a cow dies, okay, who cares? I think they have an emotional connection to it. Well, people, this puts an enormous burden to the application writer that he or she has to manage multiple VMs and create new ones when a VM fails. Most people can't actually do this right now. People will set up their VM, their file server or their mail server. They'll configure it the way they like. They want it to remain alive if something goes wrong. They love it. It's their pet. They take care of it. And Ganeti is very good at managing this kind of VM. So what we're trying to do is we're trying to combine Ganeti's reliability in handling VMs, with Synnefo's offer of flexibility and well-known cloud APIs. We're exposing the OpenStack APIs. We're not using OpenStack code, but we're exposing OpenStack APIs. You can speak to Synnefo as if it was an OpenStack installation, and use JClouds or any cloud. We've used this kind of libraries. And why is this approach good? Because it's much more manageable. We can upgrade things independently. So how are we using what we're using? We're using Synnefo to provide the OpenStack APIs to the outside world. We're using Ganeti to actually manage the virtual machines, using multiple Ganeti clusters at the back end. So Synnefo receives OpenStack commands and translates them and commands. We're using PRVD inside Ganeti to provide reliable machines without any storage array. And we're also using Archipelago to provide link loads and snapshots for virtual machines. We're using Archipelago to provide a unified way of handling storage, the way we described in my couple of slides. We're using Ceph as a backend to Archipelago, and we're exposing the OpenStack API. This is the overall picture. Don't try to grasp every single detail. The idea is that Synnefo is all the way up on the top. It's a thin layer equivalent in Python. It uses multiple Ganeti clusters for handling the VMs, and it uses Ceph backends for handling the actual stuff. What can we do with this? And what would I demonstrate today? What do we mean by unified storage? We have a file storage service, right? Users can upload files to their file storage service. They can do it in a Dropbox-like way, in the sense that they synchronize the file with partial transfers. If I have a 10 gigabyte file, I change like 4 megabytes in it, then I can re-upload it to my storage service, and don't need to upload those 4 megabytes that have changed, right? And I can do it with files. Well, we treat images, the templates for building VMs, the exact same way as files. Images are files. We don't use a different service. We don't use a different storage backend. It's the exact same backend, the exact same files, plus some custom metadata. And that's a good thing because you can re-upload your huge Windows or Debian image in seconds. Have you ever tried uploading an operating system image over a 3G connection? Let's say a 5 gigabyte image. Would it work? How long would it take? It would be more or less a disaster. Well, you can do it because if somebody else or you has previously uploaded a similar image, then you only need to re-upload what's actually meaningful for re-uploading, the change flows. Right? And then you can share files with your colleagues, right? You can share your pictures from your vacations or something. You can do the exact same thing with the exact same APIs for your images as well. We use the same template. Because, images are files. Okay, let's move a bit forward. You now want to, so you've got your files on your storage service, and to register them as images, you add the required metadata. It's a Linux image, it's got this item, and so on and so forth. And then you can create VMs for these images by cloning them into live disks, into bodies. And this also happens in a unified way. We do it with thin clones. The data doesn't actually move. And then after some time, the VM keeps working and keeps producing data. And then you need to snapshot it back. So you create a snapshot from a live volume into a snapshot file, which again is an image, which again is a file. So you can actually go download the last day's backup with in a synchronized fashion. You say I want to snapshot my VM once every 10 seconds or once every minute anyway. And then you can go sync this snapshot back to your machine and you don't need to download the change process. And all these things, they remain in the same Archipelago storage backend. We treat them uniformly, right? This is what I'm going to demonstrate. If you feel the need to ask something, please do. Okay, we can make it a more interactive presentation if you want. So, what I'm going to be doing is, first I'll switch screens. Okay, so this is a demo installation of the latest and greatest Synnefo version. It's a development snapshot. I hope it works. If you can just disable your Wi-Fi, because it's way too slow. And I don't even want to describe things, I want to show you them. That's too slow. And certain things just don't seem to work. I could try to, I don't know, start again or something. Okay, let's try. If it doesn't work, then we abort it and we just describe things. No, it doesn't work. Should I create more masters? I have FOSDEM, which was I did try everyone, but it wasn't too slow. Should I have FOSDEM? Was live connectivity because, if it doesn't work, all I can do is point you to the demo side and we'll continue. Too bad. You have to see it for your own. So, yeah, you can. It's at demo.synnefo.org. The demo is open to everybody. You can log in with your Google account, with your LinkedIn account, with your username and password combination. The IPs are not public because we don't actually have that many IPs to provide to people, but you can connect to the ISSH or ISSH your VMs. So, all I can do is describe it. Sorry for that. But if you want later on, when things have subsided, I think with the network, we can even do administration once one to one. Why are we using Ganeti? Ganeti is a tool for managing virtual machines. You give it commands, please create this machine for me, and it executes them on multiple nodes. These nodes are called a cluster. Ganeti has multiple drivers for handling storage. We have actually contributed some of these drivers. We're one of the biggest external Ganeti contributors. All these methods, all these external storage ways of drivers for handling storage, we can use them on Synnefo. And we expose them all the way to the user. The user can pick on which kind of storage backend user care VM will run, depending on the intended usage. The user can pick, I want a DRBD-based VM, where two nodes synchronize the data for migrations, or I want an Archipelago, an RBD-based VM. And we use Ganeti on the old API, just in few commands. So this is the overall picture. The user comes from a command line client, or from the web interface. They use the standard OpenStack API, the OpenStack Node API to that, for example. and we convert commands to individual direct classes. We have an integrated identity service with all the stack codes, 3-4 logs. It was a nice little command to take care of boundaries. It can support multiple authentication methods, Google-based logins, LinkedIn-based logins, Twitter-based logins, classic human passwords. We have it integrated with our shared infrastructure. We also provide services to our home European community via Educate. If you have an academic account with a European university, you can actually go and use our production suite with your own credentials. We do quotas on our those. Our compute service is a thin layer in Python and Django that only needs to implement the OpenStack APIs without actually doing the hard work. It passes the hard work on to Ganeti. Networking is pluggable via Ganeti side scripts. We can do multiple methods of isolating virtual networks, either using string VLANs, which does not scale greatly if you're on the 5,000 user stage. We can do MAC address-based filtering on a single VLAN to provide inclusion of multiple virtual networks. We can do VXLAN encapsulation. All these we provide in sample scripts. Or you can run your own if you want to roll those into external language. So that's the overall picture. The identity service is the view. The compute service and the service both speak to you. How do we interact with Ganeti? An external command comes, we ask Ganeti to actually make it happen. This is the effect part. Something happens in a Ganeti cluster, we learn about it, and we update user visible state. Why is that good? Because the administrator always has a side path to the Ganeti clusters. So even if Synnefo goes down, or even if you're upgrading it, or even if it's not the most stable code on earth, because this does happen, something breaks, your VMs are still there, they're still managed by Ganeti, you can still go and migrate them if something happens. And then the control path comes back up, and then your users can have access to the VMs to control them. But the VMs were never done. And we're actually doing this right now in production. We've done numerous rolling upgrades and kernel reboots, and nobody ever knew a thing. We migrated VMs from node to node using Ganeti commands, and nobody understood that thing. Now, let's go to the unified storage part. Our storage service exposes the Swift API to the outside world, plus extensions for efficient synchronization. What are these extensions? Every file gets chunked up in blocks of individual 4 megabyte blocks. When I want to upload a file, I ask the server, I want to upload that file with these specific blocks. I hash them individually. These are content addressable blocks. I ask the server, I want to upload these specific blocks. If you have them already, the server replies with the missing blocks. So I only need to upload these. When I want to download that file, I ask the server, what's the list of names for the blocks that comprise this file that I want to download? I compare it to the blocks that I already have, and I only need to download the missing blocks. Does this make sense? Why is this important? Because if your images are huge files, you can do partial uploads and downloads, and be much more efficient. All of this starts by Archipelago. Archipelago is a common storage backend for files, images, snapshots, and volumes. And Archipelago is backed by Ceph. So what is Archipelago? On one hand, we have resources. Resources are files, images, volumes, and snapshots. All of these things are handled as maps to individual blocks. Blocks are stored on a storage backend on Ceph. We decouple the snapshotting and the cloning logic from the individual physical storage. Let me move on and show you. These are files, my Dropbox files. These are images, files on which I have provided custom images. These are volumes, live VMs. These are snapshots. I have my image. I clone it into a running VM. My running VM, I'm going to freeze it onto a snapshot. How does this happen? I've got the snapshot about this. I clone it into a live disk. How do I do that? All of these things are handled as maps to individual blocks, and the blocks are stored on individual backends. And Archipelago is in the middle, handling this kind of mapping. I've got my golden Debian image. I want to spawn 100 virtual machines from it. Fast. How do I do it? I do not copy the individual blocks to create 100 individual disks. I just copy the mapping and refer to the original blocks. These are my 2 VMs. They each have 3 and 2 disks. These are just linear block ranges. How do I go from commands on the disks to my actual storage? On the left-hand side, the VM says, I want to write to block 5. I want to read from block 6. On the right-hand side, I speak to my storage packet, which is Ceph, and I say, write this block, or read this block. How do we bridge these 2 words? How do we translate from VMs, writing individual block numbers, to actual storage on named blocks? In the middle is the Archipelago core. It knows the map behind every resource. The volume composer will receive the block request, translate it, and give it to the backend. We have northbound drivers. For example, we expose this volume as a linked block device. This is a kernel driver. Or we could expose it as a file for people to download. Or we could expose it as a user space drive for kernel. We receive this command, and then we use southbound drivers to a Ceph packet to bring it block. Initial implementations were based on NFS. Our southbound driver to drive and bring it from NFS file. The upper layers didn't know anything about it. So we were able to do clones and snapshots over NFS. When we wanted to leave NFS, we migrated all the named blocks, driving ZipSpeed, from NFS files to Rados objects. And nobody was doing it. Archipelago has not been tried. We're experimenting. A Rados driver for Ceph and a file driver for NFS. This is the southbound interface. The northbound interface, we've got a kernel block driver for exposing block devices to the kernel, a kernel driver for exposing user space drivers, and an HTTP gateway, which actually makes the files appear, the volumes appear as files over switch. And this is how the actual mapping happens. This is a read-only map for snapshot. We clone the snapshot into a read-write map. We just have to copy the map. Whenever a write operation happens, we copy the blocks so that we can do copy and write. And we write on the copy. Then we can snapshot the volumes back into a read-only map. And this happens for everything. This happens for files, for images, for snapshots, for volumes. This is the overall picture of running the Archipelago on the infrastructure. VMs speak to the kernel block driver. It translates to Archipelago to commands from the individual storage service. Or users can speak to our web server, speak to our HTTP gateway, and use Archipelago to access their snapshots and their images over the web. I won't be speaking about this because I'd like to leave some time for questions. Why is it a good thing? Why does it work? We can do independent Ganeti and Synnefo upgrades without the user noticing. We can do Synnefo bug fixes without the VMs going down. We do not have a single database holding all VM information. Some information is held inside the Ganeti clusters, the live VM information, migration stages, and so on, and the cloud stuff is held in our own database. The cloud nodes, the Ganeti nodes, they do not have access to our own database. It's a more distinct way of seeing things. We have been able to do node evacuations in production, live migrations. We're able to do across data center from input to AMD machines. Nobody understood a thing. We're able to do migration from NFS to routers. Nobody understood that their blocks were moving. We have scaled from a few physical hosts to in the order of hundreds of hosts, now about 300 hosts. We're able to add Ganeti clusters dynamically for laser scaling, and we expose all choice regarding the storage backends to users. This is our website. You can go download the software, you can go experiment with our demo installation. I really want to give it a try and, I don't know, show you the demo side at least. But it doesn't seem I'll be able to do it anytime soon. Thanks for your attention. Would you like to ask things, talk about things? Yes?
Hi, I'm Luis Becciari. I'm a Ceph developer, and the feature release of Ceph has been delayed 2 weeks. So would you like something to make your life easier?
Yeah, we'd like scrubbing to have less impact on production systems. Because we are running Ceph in production right now. And they're working beautifully, but when they start scrubbing or deep scrubbing things, the OSDs go, they are almost inaccessible. So we had users complain that their I/O operations didn't complete, and had to stop scrubbing with the tide to make things come back to normal. It's in the order of tens of nodes, about 20 physical nodes. It's in the order of a few petabytes, 1 or 2 petabytes. We have had issues with latency. Radius imposes quite some latency. If you're doing network-based I/O, we have latency, and this shows in the VMs. So we cache as much as we can near the clients. We have a caching version of Archipelago, which caches on the clients, and only does the actual I/O. The VM says, I want to sync this back to this. I want to keep the magnetic plate to this. We're over at 10 Ethernet, we use the same data center. Yeah, but if you're doing 4K writes with 1 or 2 outstanding requests, you can, half or 1 millisecond latency shows. How large are our Ganeti clusters? We're trying to keep them pretty small because they're much more efficient and responsive this way. We're trying to keep them in the order of 15 nodes. We don't have to do it, but they're pretty loaded right now. And since we're exposing a cloud service, we do have a very high request rate to Ganeti clusters. So we're keeping them at about 15 or at most 20 nodes. So the question is, if we're cloning a golden image to a VM, we still use TRBT? No. If the user selects TRBT, I could actually demonstrate it. So please go and see the network staff operation. So, not guaranteed, but we could do it. So here's the thing. I'll repeat the question for you, but you're saying, if you want to do thin clones of a golden image, can we do it with TRBT? No. If you select TRBT as your storage, you'll experience a 5 or 10 minute delay until the image is copied from our blocks to TRBT. That's what we're doing exactly. We're DTing. But if you use Archipelago-based storage, we know they're backed by the same buckets, so we just say, let's clone this into 100 folders. What's the question again? Well, doesn't, yeah, but this would take 5 minutes by 100. But this would take 500 minutes, right? And then your networking would be the bottleneck because you know the project has to be, and you don't really want to do it for short-lived 1 or 2 week VMs, for example. If the user wants this VM to survive for a year, a mail server, then we will create it with your DB. Otherwise, we're giving the option to be used.
So you have always got like the quota in order to
yes.
Some guys can use it and start IO 100 nodes so that your customer accounts.
We have cloud-level quotas in the sense that every resource is accounted for. We have a nice dashboard which feeds. Oh, of course. Let's see. Okay. Let's please no forms already. Let's see. Okay. These are dashboards. This is our storage space on Mythos. I've given myself humongous amounts of data. Okay? These are system disks, number of CPUs, amount of RAM, number of virtual machines, number of virtual networks, and number of basic IDs that the user has allocated. So we limit the number of VMs, for example, that the user can create. We don't actually do I/O-based limitations right now, but we do plan to do this. Follow flows and enforce quotas on individual flows. Let's say the total number of IOPS per user, by combining user flows, will leave this much. We don't currently do this. Yes, please. Okay. Sure, but how do you do that? Eventually, yes, they are set to the system. Okay, this is an interesting question. The question is, yes, that's what I'm going to do. If the snapshots and the images are stored on our storage system, Mythos, that's how we call it. If something comes to the data center, what happens with availability and reliability and robustness? Do they get destroyed? Well, our storage system currently, a single installation lives inside a single data center. But then if you have 2 Mythos installations, 2 different regions, if you have one here and one in Athens, for example, the very fact that we account for individual blocks allows you to very efficiently synchronize your important files to a very remote region. You can say, every night, I'll be fetching maps from region A and comparing them with maps from region B. And I only need to transfer, as a user myself, right? I only need to transfer that many blocks, the ones that have changed. We could even automate this. What we are doing is, Mythos exposes the maps to the API so the users can do themselves if they want. They can synchronize the files themselves. But then, since we're using backends without actually knowing what we're doing, if Ceph, for example, at some point acquires the ability to do asynchronous replication sample without actually impacting the performance, without actually being synchronous, then we can take advantage of it, right? Because we're agnostic to the actual storage backend being used. But even now, we can automate at the API level. Did I actually give you a bit of attention to get the feedback? We provide statistics over the API. We provide, the question is, if you have a if you have a traffic spike, can you automate the process of creating up new VMs? We provide statistics over the APIs. We can say, I want CPU or network statistics for my VMs. We provide the ability to thinly create VMs over snapshots. The infrastructure currently does not provide an automated way of looking at the statistics and deciding who's spawning VMs. But you can do it your own if you want. If you feel that a certain set of VMs may come under great load, you can make requests about their load and automatically spawn new VMs. But we don't have infrastructure that does it automatically. The metrics are hypervisor metrics. We look at the Linux kernel. We provide CPU and network boundaries for every VM. Yes? Please go to the demo site and see how everything works. I mean, or if you want, we can steal some minutes. Okay. Other questions? We can continue.